Let us see how to obtain minimal polynomials of Galois field 2 raised to 3. Primitive polynomial is x cube plus x plus 1. So this primitive polynomial is used to obtain the field elements. And we have already seen that alpha square alpha raised to 4 forms one set of conjugates, and alpha cube alpha 5 alpha 6 forms another set of conjugates. We have also obtained this equation if the primitive polynomial is x cube plus x plus 1. So that is alpha cube is alpha plus 1, alpha raised to 4 is alpha square plus alpha, alpha raised to 5 is alpha square plus alpha plus 1, and alpha raised to 6 is alpha square plus 1. Alpha raised to 7 is 1, because Galois field 2 raised to 3 means Galois field 8. If it is 8, then alpha raised to 7 will be equal to 1. Alpha raised to q minus 1 equal to 1, and q is 8. So this we have already discussed in a very I think in 2 to 3 videos we have discussed all these things. So in this video we will directly jump on to finding the minimal polynomials. This background we have already covered in the previous videos. In depth we have seen how these points we have covered in depth in previous videos. So let us see how to obtain the minimal polynomials. And in exam also, if they have asked you to obtain the minimal polynomials, you can directly write all these things depending on how much marks are there for that question. If it is for a few less marks, then you can directly write that alpha square alpha raised to 4 forms one set, then alpha cube alpha raised to 5 alpha raised to 6 form another set. So let us obtain the minimal polynomial of alpha. Minimal polynomial of alpha means you have to take alpha square alpha raised to 4. So that will be x plus alpha square x plus alpha raised to 4. So if you multiply this and this, then you will get first we will multiply x with all this. So x square plus alpha square into x, then alpha into x and alpha cube, then remaining is x plus alpha raised to 4. First you have to multiply these two or any two. So x square, then x we have taken common, and then it will be alpha square plus alpha cube. This we are not doing anything right now for this. Then alpha square plus alpha is equal to, you have to see what is it. It is alpha raised to 4. So write down alpha raised to 4. Then alpha cube x plus alpha raised to 4. In doing this calculation, you have to reduce the elements. That means if you are getting alpha square plus alpha, don't take it too long till the end. Here only you have to write it as alpha raised to 4, so that will be easier for you to do the calculations. If you write alpha square plus alpha every time, then it will also take a lot of time. So write down alpha raised to 4. Then after that you have to do the multiplication from this and this. So multiply with x, it will be x cube, then alpha raised to 4 x square alpha cube x, then with alpha raised to 4, so alpha raised to 4 x square, then alpha raised to 8x, then alpha 3 plus 4 is alpha raised to 7. So directly here you write alpha raised to 7 is equal to 1, because you know that alpha raised to 7 is equal to 1. Then x, then here x cube, then x square common is then common terms are alpha raised to 4 and alpha raised to 4. Then x common terms are alpha raised to 8 and alpha cube. Then alpha raised to 4 gets cancelled out. Then x alpha raised to 8 is alpha raised to 7 into alpha plus alpha cube plus 1. Alpha raised to 7 is equal to 1. So that will be x cube plus x into alpha plus alpha cube plus 1. Now alpha cube is alpha plus 1, so alpha gets cancelled out, so you will get x cube plus x plus 1. So this is the minimal polynomial you are getting with the roots alpha square alpha raised to 4. So let us obtain the minimal polynomial for alpha cube. So So the its conjugate sets in its set, its conjugate members are alpha 5 and alpha 6. So minimal polynomial is x plus alpha cube plus x plus alpha raised to 5 x plus alpha raised to 6. So multiply first two brackets. So it will be x into x square, x into x square, x into alpha raised to 5. Okay, here x square into alpha cube x, then alpha raised to 5x and alpha raised to 8. After that x plus alpha raised to 6. Then x is common, then alpha raised to 5 alpha cube. Alpha raised to 8 is alpha raised to 7 into alpha. This is as it is. Now alpha raised to 5 is equal to alpha square plus alpha plus 1. That we have already seen. Alpha raised to 5 is equal to alpha square plus alpha plus 1. So alpha square plus alpha plus 1, alpha cube is alpha plus 1, then alpha raised to 7 is 1, so that is alpha. So these this table also you need to know to find the minimal polynomials. So this is alpha square gets this will be alpha gets cancelled out, 1 gets cancelled out, so it will be x square plus x alpha square plus alpha, this alpha, then x plus alpha raised to 6. Then again you have to multiply x with the first bracket. So x into first bracket, that is x cube plus x square plus alpha square, sorry, into alpha square plus x alpha, then alpha raised to 6 into x square, alpha raised to 6 into 8 into x, then alpha raised to 7, again alpha raised to 7 is 1, then x cube x square common is alpha square alpha 6, x common is alpha and alpha 8. Now square alpha raised to 6 is equal to alpha square plus 1. So this polynomial representation of the elements will be obtained with the primitive polynomial, that we have seen how to obtain the how to construct Galois field 8 2 raised to 3 with the primitive polynomial x cube plus x plus 1. So these values we have already seen. So alpha raised to 6 is alpha square plus 1. So here, where is it? Here. Alpha raised to 6 is alpha square plus 1. Then x alpha 8 means alpha 7 into alpha plus 1. Then alpha square gets cancelled out. It is x cube plus x square. X alpha 7 is 1. Alpha plus alpha plus 1. Alpha plus alpha is 0. So x cube plus x square plus 1 is the minimal polynomial of alpha cube. We say alpha cube, we are taking the first element. These are its conjugate friends or conjugate members, and these three forms the set, which is called conjugate set. That means the roots of the same minimal polynomial. So the elements are 0 1. For 0 minimal polynomial is x, for 1 it is x plus 1. For alpha square alpha raised to 4, the minimal polynomial is x cube plus x plus 1. For alpha cube alpha 5 alpha 6, minimal polynomial is x cube plus x square plus 1. Now the interesting point is that it is Galois field 8. It is Galois field 8, which is Galois field 2 raised to 3, which is also called extension field, which is obtained from base field Galois field 2. So if Galois field 8, then you can write it is as x raised to 7 plus 1, q minus 1. Q is 8, so q minus 1 is x raised to 7 plus 1. Either you can write plus or minus. It is plus or minus, x raised to 7 plus 1 or x raised to 7 minus 1. That will be equal to we have seen this equation in previous videos. That will be equal to the product this term has the factors which are all the non-zero elements of the field. So if it is Galois field 8, then x raised to q minus 1, that is x raised to 7 plus 1. This plus 1 has the roots 1 alpha square alpha raised to 4 alpha cube alpha 5 alpha 6. Same is written here. So it has the roots 1, then alpha square alpha 4 cube 5 6. Now these three elements forms one minimal polynomial, and these three elements form another minimal polynomial. So we do some statement about minimal polynomials is that minimal polynomials are factors of x raised to q minus 1 plus or minus 1. Q is here 8, Galois field 2 raised to 3, that means 8, which is obtained with Galois field 2, which is a extension field. So x raised to 7 plus or minus 1, plus or minus. If you have taken here minus, then you have to write x minus 1, x minus alpha square. But in Galois field 2, plus is equal to minus, because 1 plus 1 is equal to 0, that is 1 is equal to minus 1. So we have seen that minimal polynomials are factors of x raised to q minus 1 plus or minus 1. Now, what is the difference between primitive and minimal polynomial? Primitive polynomial is, this is the primitive polynomial. So this polynomial is also a minimal polynomial. Primitive polynomial is also a minimal polynomial, but it has root primitive element, that is alpha. It has the root primitive element. It has one of the root as primitive element, and this primitive polynomial is used to construct the extension field, because the elements here, the equations we have found for the elements are with mod of primitive polynomial. So these equations, to get this equation, we use the primitive polynomial. So that is the difference between the minimal polynomial and primitive polynomial. Both are the factors of x raised to q minus 1 plus or minus 1, but primitive polynomial has one of the root as alpha, and primitive polynomial is used to construct the Galois field, extension Galois field, or Galois field 8 here. So that means the equations that you have seen about all the elements, that is obtained with the mod of primitive polynomial. So that is the difference between minimal polynomial and the primitive polynomial.